Good morning, all. I'm so sorry this didn't post yesterday, but for some reason, it not download, so I had to re-record it this morning. So, let's go. Okay, so this is the area of regular polygons, and I just want to refresh your memory on what the definition of a regular polygon is before we get into it. This is a polygon with all sides congruent. I don't know why I saw 20 there. It's a polygon with all sides congruent, all interior angles congruent, and all exterior angles congruent. So a regular polygon, I'm just going to draw a quick triangle. Remember, it would look like this: all sides equal, all angles equal. All right, so let's go ahead to the next slide. All right, in order to find the area of these, you're going to need to understand some of the basic parts of regular polygons. The first part is the center. The center of the regular polygon is going to be the same as the center of the circumscribed circle. Circumscribed means like circumference, it goes around the circle. So circumscribed circle is that circle going around a figure. And it can't be like this, that's not considered circumscribed. To be circumscribed, all of the vertices have to be on the specific shape. So again, it has to be um, excuse me, the radius of that circumscribed circle. So, I'm sorry, the center of that circumscribed circle. So there it is, and it's the center of the circle that is going around here. So, all right. Anyway, next term is the radius. Now, the radius of the polygon is going to be a segment with one endpoint at the center here, and then the other endpoint is going to be one of the vertices. So by one of the vertices, we're talking about these here. These are our vertices is plural. So these are our different vertices of the polygon. And this is going to be a radius. It starts at the center and goes there. So there will be a total of, in this case, as it's a pentagon, there will be 5 radii for this particular polygon. And note that the radius is also a radius of that circle that's going around. It's also a radius of that. Next term is the apothem. Now the apothem is a segment with one endpoint at the center, and the other endpoint is the midpoint of a side. So this is what, I'm going to just erase this one down here. This is what the, oops, whatever. You get it. This is what the apothem would look like. It's going to have one endpoint here at the center, and then the other is the midpoint of the side. So this is the apothem. Now there's one specific part of the definition that's also important. It says the segment is perpendicular to the side. So it has to be perpendicular to the side. So essentially, you can kind of think of the apothem as being a perpendicular bisector of the side. And just like you had 5 radii, you could have 5 different apothems depending on which side you're drawing it to. Here would be another one. Here would be, I'm not going to draw them all, but there will be 5, going to each side. And again, it's a perpendicular bisector of the side. All right, next. And then the next term is a central angle. A central angle is an angle, with the vertex at the center and the sides pass through adjacent vertices. So I'm just going to do this on the one down below here. The one down below here is a hexagon, but it's the same situation, a regular polygon, all the sides are congruent. And to be a central angle, here's the center, it's at the vertex. I'm sorry, the vertex is at the center. And then this is an example of a central angle. Now, if we look at the definition, it says the sides pass through adjacent vertices. Again, our vocabulary, adjacent means next to. So these would be adjacent vertices. This is the center, and the sides pass through adjacent vertices. This is the central angle. This would be another central angle here. So 1, 2. This would be another one here. 3, 4, 5, and 6. So there will be 6 here. For this one up here, just to be more thorough, this would have been another central angle up here, 2, etc. So next, oh, not next, excuse me. you do need to know how to find the central angle measure, and the way you find the central angle measure is just doing 360 divided by the number of sides. Is going to be 360 divided by the number of sides. So for the pentagon up here, it would be 360 divided by 5. So all of those central angles would be 72 degrees. Just realized I don't have my calculator. And 360, but I do know how to divide some things. 360 divided by 6, that would be 60 for all of these. All right, and the next slide is the interior angle sum. Now, this is something we've already done, and when it comes to the interior angles, what you need to remember is what we were doing in the, not the last chapter, but when we were dealing with the polygons, and the way you find that is going to be the number of sides minus 1, the number of sides minus 2 times 180. So let's say for the pentagon, it would be, the hexagon, it would be 6 minus 2. So it'll be 180 times 4, times 4. So for this, it'll be 720. And remember, once you find that sum, this is like for the sum. If you want to find the specific ones, you would divide it by 2. 6. And for the hexagon here, they would end up being 120 degrees. Now, what we're finding, just erase this, when you're finding that, if we go back to the polygon, make sure you're thinking, it's going to be these angles. These are the interior angles. So each one of those is 120 degrees. And just an important note, when you do draw in the radius bisects these angles. So they would be 60, 60, 60, 60. All right, next slide. The way you find the area of a regular polygon is not really too difficult. Here's the formula. The area is half AP. The A in that formula stands for apothem. Just talked about what that's going to look like. The apothem is that perpendicular bisector. Of the side. So it'll be the apothem, half the apothem, times the perimeter. And the key thing to remember with the perimeter is that the perimeter, all the sides are equal. So it should be relatively easy to find the perimeter. So I have a couple of examples here on this first slide. Probably only going to do like 2, just because it's not, this formula is relatively easy. Even though I have this more elaborate table, we're not, with these basic ones here, we're not going to do the whole elaborate table. We'll do those for the next slide or two. But for this one, we just need to find the area. So for this first example here. Now, first of all, if you had a square, obviously you would not go through the process of using this formula. You would just do 6 squared and get the area as 36. But this is just, to show you that it will work even with something you know how to find the area another way. So it's going to be half. For this first example here, the apothem is 3. And the perimeter, again, would be all 4 sides. So in this case, that would be 24 since all the sides are equal. And then let's multiply that out. It's going to be half of 72. And half of 72. Oh, excuse me for yawning. It's 36. All right, let's move ahead. Let's look at the last one. This one over here with the hexagon. Hexagon. So let's do 4. Because again, these you should be able to do pretty easily. So it's going to be half. Move this over a little bit. It's going to be half the apothem. Times the perimeter. So the perimeter for this one is 14 all around. 14 all around is 84. All right, now she needs her calculator. So for this, now we're going to multiply this. It's going to be 42 times 7 root 3. Sorry, trying to make the math a little easier for myself since I don't have my calculator. It's 294 root 3. All right. Next. All right, so on the next slide, as you can tell, all right, so the next slide, same thing, but as you can note here for the directions, we're going to do this with the specials. This side has, I think, 2 triangles. The next one has some hexagons and squares or whatever. So I'll just do like one of each, and hopefully that's enough. If anyone feels like they want me to do another example or two, just let me know, and I'll at least post the answers for it. But I don't want to make the video too long because they're getting obnoxious. All right, so let's go with this here. So for this one, this is a triangle, regular triangle. So again, I know for this, I'm starting off with a radius of 10. So I'm going to fill that in. It's 10. And that means this is 10 here. In the triangle, this little shape inside here is a little off. It's bothering me, so let me move this over. But in the triangle, the central angle is going to be 360 divided by 3, which is 120. So again, that means this whole angle over here is 120. Now, I need half of it because the apothem splits that in half. So since the apothem splits that in half, this angle in the triangle is 60 up here. Now, I say with the specials, in the couple that are in the packet or on the exit card tomorrow, you'll see that it will be in radical form. So make sure you're comfortable with doing it in radical form. So for this one, essentially I have a 30, 60, 90, and this is the long leg, or I'm sorry, this is the hypotenuse, it's 10. So this is going to be 5, because this is 30 here, and then this is 5 root 3. So the apothem is 5, because this is my apothem, and the side, again, remember it's all the way across, is going to be 10 root 3, because it's 5 root 3 twice. The perimeter is therefore going to, 3. 10 root 3. The perimeter is therefore going to be 30 root 3. And the area would be half the apothem times the perimeter. So it's going to be 75 root 3. Again, there's another triangle. We're going to skip that. Let's go to the square. All right, so on this page we have some regular squares. Again, I have 2 here. I'm only going to do 1 to try to make the video a little shorter. So for this one, for the square, again, this time I'm starting with the radius. So let's write that in. It's 10 root 2. And in a square, it's going to be 360 over 4, which is 90 degrees. So again, move this over a little bit. But this is what that's going to look like, and this is 10 root 2. Since the central angle was 90, the apothem split that 90 into 45, 45. So this is going to be 45 up top. This is going to be 45 up here. So I'm dealing with a 45, 45, 90, where the hypotenuse is 10 root 2. So these are both 10. The apothem is 10. The side is going to be 20, because again, it's 2 of the 10s, which means the perimeter is 80. So for my area, it's half the apothem 10 times the perimeter, which is 80. So that's going to be 400. All right, next slide. And the last one that's going to help us have a special when it comes to the regular polygons is our hexagon. I think I put 3 of those here. So I guess we can do 2 of these if time doesn't look too crazy. So let's begin. With the hexagon, the central angle, for this one we're starting off with the radius is 4. I'm sorry, write that in. The central angle we already discussed a few times is 360 divided by 6. So in this case it's 60. Again, the apothem is splitting that, so we end up with a triangle that looks like the following. 30 up top, and this is the radius, which is 4. All right, 30, 60, 90. If the hypotenuse is 4, the short leg is 2, and the long leg is 2 root 3. So filling in, our hypotenuse is 2 root 3, because it's this long leg. Our side is going to be 2 and 2, because it's half of it here. So it's 4 as well. And our perimeter is therefore 24. And our area is going to be half the hypotenuse, 2 root 3, times the perimeter. Our answer is 24 root 3. All right, and let's do one last one. We'll do number 9 here, and that'll be it. So for this one, we're starting with the side. The side is 6. Now what's happening, so do not put 6 in the triangle. Again, it's being bisected, so this will be 3 and 3. So for the triangle that we blow up and are looking at, this is 3. This is 30. Again, we already talked about the angle in the other one. So we could figure out the perimeter, I guess, quickly if we wanted to. 6 times 6, perimeter is 36. All right, so now let's get to everything else. This will be 3 root 3. This will be 6. So the radius is 6. Can't use yellow. Radius is 6, and the hypotenuse is 3 root 3. And therefore the area would be half the hypotenuse, 3 root 3, times the area, times the perimeter, 36. 18 times 3 is 54. So 54 root 3. All right, that's it, guys. I'll post the other answers.